My name is Rui, and if you want to succeed in modern manufacturing, then pay close attention. Thank you so much, first of all, for attending this podcast. And your side, we have Alberto. Okay, we wanted to discuss a little bit about our solutions that are in development right now. So regarding the solutions, can you give us a brief explanation about what you are developing?
Aeropotechnic solution will take aerial inspection to the next level because we know that thermography is a technique that today is widely used in photovoltaic farms, but it's not just everything. So we hope to bring the aerial inspection to a next level, both with developing and deploying some new inspection techniques. So beyond thermography, and also massively use AI/ML in order to scale times, reduce costs, and keeping the accuracy as high as our PV sector needs.
Okay, very well. And can you give us a brief explanation of how has the aerial technology revolutionized the way, like, for example, large scale PV farms are maintained and inspected throughout time?
Yes, so as we were discussing before, the first application of aerial technology, and particularly when we speak about aerial technology, we speak about drone, for maintenance and inspection of photovoltaic farms is for sure aerial thermography. And the integration of a thermal camera in a drone has brought some advantages. And we can mention, for example, that it's possible to perform a rapid, efficient, and scalable inspection. So drones equipped with high-resolution cameras and thermal imaging sensor can inspect big solar farms in a fraction of the time if we compare them to traditional manual inspection. And also, automated flight paths ensure comprehensive coverage with minimal or no human intervention. So no part of the farm is forgotten.
Okay.
Then we can mention the enhanced accuracy of the inspection. And that's why we have a high quality thermal sensor, and we have the possibility to adjust the incidence angle in order to get the maximum emissivity from the modules. And the automation associated to the use of drones guarantees a level of uniformity of the imagery impossible to achieve with manual inspection. We can also mention cost reduction because, well, there is nothing difficult to explain because it reduces the need for manual labor. And we have to mention also a very important point, that is safety. So the drone is much safer if we compare it to manual inspection. In this field, PVOP has been studied and developing solution to grow the service offered beyond aerial thermography. And we can mention aerial electroluminescence, aerial detection of microcracks, aerial reading of serial numbers from the labels of the modules, aerial UV fluorescence, aerial detection of misaligned trackers, aerial detection of hanging DC cables, and aerial vegetation management. The vegetation management doesn't mean that we cut the grass from a drone. This will be a dream. But we can, with a drone, we can indicate the areas that are prioritized for intervention of vegetation tree.
Okay. So you are mentioning a lot of the benefits that are entangled with this solution, right? One of the things is obviously the reduction of human labor. So how can autonomous inspections in this case reduce the human labor burden while also improving accuracy and safety?
So if we have an autonomous workflow, we have no need to upload the data and analyzing them, because synchronization with the cloud and the AI/ML routines for that analysis will substitute the human labor burden. So interested people receive in a matter of minutes the inspection results in their email, And so corrective actions can be triggered immediately, and there is no delay between the data collection and result in the client's email.
And what makes this aerial inspection system fully autonomous? And how does it ensure consistency across inspections?
So the aerial system is fully autonomous because it is based on pre-programmed routines to carry on the flight, upload the data, analyzing them, and reporting issues to whoever we want it to receive. The unprecedented data harmonization and standardization enabled with autonomous solutions ensures that photos are collected always in the same location, and that's because we use RTK, and RTK error, as you probably know, is as low as 4 centimeters. And so the photos are also collected with the same camera parameters and the same settings. So having all the photos collected in the same way, we have an optimal accuracy for the AI/ML algorithms, so we can analyze them with a good accuracy, and we minimize both false positives and false negatives.
Okay, so one of the key questions regarding for a lot of businesses and a lot of investors, owners of asset owners as well, is how can we integrate this technology and new solutions in existing platforms that they already have? So how are you ensuring this with your system?
Yes, so the integration between our autonomous aerial system and another fall detection system can be done in multiple ways. For example, a drone can be deployed autonomously in the area where a fall detection system has detected some issue in order to investigate further and provide additional insight in the final report that will be delivered to the client. And in this point, one key point of PVO project is the goal to interconnect in multiple data sources. So a fall detection system like an airborne data collection will share its finding with other data systems. So we merge all the inputs together and we provide a real digitalization of the assets.
And are there any data security and privacy considerations when you are deploying this?
So as PVO, we own entirely the intellectual property of the solution. So no third-party provider is involved when it comes to data transfer, storage, and processing. Okay. Data from the field are uploaded directly in Aeroprotectness servers and here are processed. And here we have in place and we enforce the most recent security best practices.
Okay. And you mentioned at the beginning that you had already some benefits, such as cost reduction, right? What feedback or results have pilot projects revealed about the effectiveness of the system and the return on investment? Do you have some cases where you've had this implemented and where this is already showing?
Yes, we have run some pilot projects and we have noticed that the potentiality of the solution is very big. The cost reduction is expected to be as high as expected, but also our pilot projects have indicated us what challenges need to be overcome and which are the most promising possibilities in order to face them. So overall, it's a very promising path that we are going to.
All right, and just going a bit to the cost reduction part again. So how much are we expecting, like percentage-wise? Do you have a number or not? Not really.
Yeah, we have some provisional number that we expect, and we expect about 80% in cost reduction if we compare autonomous aerial system to manual state-of-the-art inspectional processes.
Okay. Yeah, I think that's all for today. That's all my questions. I don't know if you'd like to add something regarding the solution and how much it is impacting right now the PV farms on a larger scale. On a positive note.
Yeah, well, I think we covered all the aspect that we would like to share, and so I don't think there are any points that we can add. But
All right, all right.
for sure, a promising path that we're triggered and happy to be into.
Great. Thank you so much. Thank you so much for listening to this episode. If you'd like to learn more about the project and its solutions, please visit the pvop.eu website and join our community on Discord, okay? The link is in the description, and you can also follow us on social media on LinkedIn. We'll see each other in the next episode. Thank you.